Dear students, in this video we are going to see chapter 2, particularly about group and abelian group. Okay. Now we see the definition of group. Okay. Now you take any set G with binary operation star, then we have to check this satisfies four conditions. Okay. First one is closure property. Second one associative property. Third one identity property. Fourth one inverse property. Okay, we will see all these four properties in detail in the next problems. Okay, you see what is the fifth one. Suppose I take a set G with binary operation star, it satisfies four conditions, then we say that this G is nothing but group. We give the name group. Okay, suppose I have group G. And I'm checking another condition. Another condition is commutative condition. The condition is this one. Okay, commutative condition. Okay. If this condition is also true for this G, then I can say that the name of G is abelian group. Okay, abelian group. Okay. Now here two examples are given. Z comma plus is abelian group and Q comma plus is an abelian group. Okay. Now we are going to see how we prove that Z comma plus is an abelian group. Okay. Now you see this example. Prove that Z comma plus is an abelian group or commutative group. Okay. Now what is Z? Z is nothing but the set of all integers, which means Z is equal to this. This is set of all integers. Okay. Now what is the binary operation given in the question? That is plus. Plus is the binary operation, but the general notation is a star. Okay. In general we say that star. Okay. Now here that is plus. Okay. Binary operation is plus. Okay. Now we see the first property, closed property. What is closed property? See how to read this. This is called for all. This is called for all. For all. Okay, this is the symbol for all. Okay, for all a comma b belongs to Z, a star b is equal to a plus b, that is also in Z, belongs to Z. Okay, this is the closed property. Okay, now here for all a comma b belongs to Z, which means you take any two number a and b in Z in the given set. Here you take any two number, then you apply the binary operation. This is the general notation. A star b is equal to a plus b. Here why I put plus? Because our binary operation is plus. In the question. So I put plus. I replace this. This is the rule a star b. Now I replace this star by our operation plus. So a plus b belongs to Z. Yes, definitely. See, you take any two number in Z, then you add definitely the answer again in Z. So that is called closed. This is true. By some example, I can show you. You see, I take two number minus 11 and 5. You take any two number, no issue. See, I take minus 11 and 5. I apply the binary operation. What is the binary operation? See, plus. So minus 11 plus 5, how much? How much answer? That is minus 6. Actually, the answer is minus 6. Okay. Yes or no? Tell me. This is belongs to Z or not? Yes, this is belongs to Z. So that it's correct. Not only for these two values. You take any two values. Okay. See, this is the that's why we are writing this for all any two values. Okay. So closed property is correct. Okay, now what is associative? Associative means you take any three values A, B, C in Z. Now check this condition. This is the condition for associative. So A star B star C equal to A star B star C. Now here star is the general binary operation, but in our question it is given plus. So now you replace this star by plus. Okay, this is the associative property. Okay, actually this is true. How it is true? Now you see the example. You take any three numbers in Z. Now apply. See here, A is 3, B is minus 1, C is 9. You apply in this rule. Then first you simplify the bracket, within bracket. Now the answer is 2 here. Here simplify within bracket, answer is 8. So you see both sides, you are getting the same value. So now similarly, you take any set of three numbers. You take 100, 25 minus 1000. you take any set of three numbers, you apply this, definitely both side is correct, which means associative is valid. Okay. Now, what is the third property? Identity property. For any element A belongs to Z, there is an identity element E belongs to Z, such as, actually this is a rule for identity. This is the rule for identity. A star E is equal to E star A is equal to A. Okay, which means this is any number in Z in the set. This element is called identity element. Then you operate these two by the binary operation. Then again you will get the same value A which you have taken. Okay. Now I take this one. I take the left side. A star E is equal to this A. Okay. What is A star E? Here star is binary operation. Here is sum is the binary operation plus. So that I put A plus E. Okay, A plus E is equal to A. Actually, this is the rule. In this rule, I take this left side and this last one. You can take this and this also. No issue. You will get the same answer. Okay. So A plus E is equal to A. Now, what is our aim? We are going to find the identity element. Okay. So now, what is the identity element? You keep identity element E one side. Then E is equal to A minus this A. That is 0. So what is the identity element? E is 0. This is also inside your Z. So E is equal to 0 is the identity element of your binary operation sum over Z. Okay. Now you see the example. How to verify this identity property for the given Z comma plus. Okay. You take any number. I take A is equal to 5. You take any number. Then already you found E is equal to its identity element. So now what I am going to check? I am going to check this property. This is the identity property. See, you take any number A. Okay. And then see here. A is 5. Then here star is plus. Okay. That's what I'm writing. A is 5. Any number. Then star is your binary operation positive. In this question, in this problem is sum. Okay. Plus. Then what is this? This is identity element 0. Okay. That's what you have calculated here. So you put here 0. So 5 plus 0 how much? 0 plus 5 how much? Because you are writing this rule. All are same 5. See 5 plus 0 5. 0 plus 5 5. So it's equal to 5. So this satisfies the identity property. So that no doubt E is equal to 0 is the identity element for Z comma plus. Okay. Now next inverse property. What is inverse property? What is inverse property? Inverse property is nothing but we are going to find the inverse of each element. Okay. In the given set Z under the binary operation plus. Okay. Now I take A is any element. Okay, then there is an inverse element A inverse, but what is that inverse? We have to find. See the condition. This is the rule. This is the rule. A inverse star A is equal to A star A inverse is equal to E. This is the rule. Okay. Now I take the left side. A inverse star A and E. I take this. Okay. I take this. Okay. Now A inverse star A is equal to E. Now what is here? Star is plus our binary operation. So A star plus A. You replace this by A by plus. Then A is equal to E. Now here A inverse. We are going to calculate A inverse. So A inverse. So you write this A on the other side. So now A inverse is equal to E minus E. Okay. So what is E? You have calculated E here. That is 0. You substitute here. So E is 0 minus A. That is equal to minus A. This number belongs to Z. Yes. Now what is the inverse? See A inverse, actually to find the inverse of any element in this set you have to see, you have to write here negative sign in front of that element. See, actually this is called inverse of the number A, which is equal to minus A. See, you can see the example here, then you understand easily. Now take the number A is equal to 5. Any number. Say I am taking 5. You take 6, 7, minus 1, minus 2. Any number you take. I am going to find the inverse. Inverse of this element. So how to find the inverse of this element? This is the rule. Inverse of any element is you put negative sign in front of that element. So now I want the inverse of 5. So what is the inverse of 5? See, you write the rule, that is minus A. So that I write here minus a. A is 5, so minus 5. So what is the inverse? Inverse of a is minus 5. Inverse of a is minus 5. So how to check this whether inverse is correct? See, this is the rule, this is the condition for inverse. So now you apply the condition, a inverse star a equal to a star a inverse is equal to e. Now here a inverse is minus 5 plus 5, see a, and then is equal to 5 a plus here a inverse is equal to, see, when you operate inverse element with the element, you will get the identity element. That is the rule. So that here we are getting 0. 0 is the identity element. Okay, this is e actually. 0 is the identity element. When you operate, when you do the binary operation between the inverse and the element, you will get the binary, you will get the identity element. Okay, so this is correct. Now what is the last property? Commutative property. What is commutative property? You take any two number in Z, then apply a star b equal to b star a. You check a star b equal to b star a. Yes, here a plus b equal to b plus a for all a b in Z. Yes, sure. But you can take two numbers. For example, you can take two numbers minus 11 and 5. Then you check minus 11 plus 5 and 5 plus minus 11. Yes, both are correct. That's why Z comma plus is an abelian group. Actually, we have another question here. We can see this question in the next video. Thank you.